This is a FET Amplifier Kit. To perform the experiment, initially you need to set 50 millivolts in function generator. So let us switch on this. Switch on CRO also. Connect probe at output of the function generator. And also connect one more probe to channel 1 of CRO. Connect function generator probe and CRO probe, positive to positive and negative to negative here. Now set the frequency 1 kHz. Here it is showing 9.82 kHz. Just by rotating this knob, frequency variable knob, set to 1 kHz. So now it is 1 kHz. So now you need to set 50 millivolts and you have to observe the waveform in the CRO. To get a proper sine wave in CRO, you need to adjust attenuation to 40 decibels in your function generator by pressing this button twice. Now in CRO, so make sure it is in channel 1. This is channel 2. Now if I press this is in channel 2, release this button, it is in channel 1. And it is in ground mode, just release this. Before that, just make this voltage, channel 1 voltage to 50 millivolts and release this ground button. So you are able to see a sine wave. Let me measure how much voltage it is. Make upside by moving a Y shift. So it is more than 1 division. Okay, make this waveform into one box of CRO. For that, just reduce the amplitude in this function generator such that you will get a one box exactly. Now your waveform exactly in one division of that CRO scale. Now this one division into the channel 1 voltage is 50 millivolts. One division into 50 millivolts, you will get 50 millivolts as input. Now I completely set the input 1 kHz and 50 millivolts. Right? Now you apply this 50 millivolts to the input of the CS amplifier, common source amplifier. Take output across the CS amplifier terminals, output terminals. Now connect input from function generator to the input of the kit. Connect CRO to the output of the circuit, and this black color pin should be to the ground. Now switch on the kit. So now you need to vary the frequency from 20 Hz to 1 MHz in regular intervals and note down corresponding output voltages. To note down the corresponding output voltages, I am putting the CRO in XY mode. So I will get one line like this. So it is easily to measure the output voltage. Now I will set the 20 Hz frequency in function generator. This is the frequency range. Now it is 10 kHz. To make it 20 Hz, you need to change this range. Yes, it is 10, 100. Now I will change this frequency knob, make it to 20. Now it is 20 Hz. To see complete wave, I am reducing this channel 1 voltage here. Yes, I put it to 0.1 volt. Now see how many divisions it occupies. Approximately 1, 2, 3, 4. For lower frequencies, there is some oscillations we will get. Okay, no problem. 4 divisions into 0.1 volt. Total 0.4 volts. For 20 Hz frequency, I am getting 4 divisions into 0.1. 0.4 volts. Please note down this value. So this is the tabular form for FET amplifier experiment. So input voltage we have taken as 50 millivolts. Now for 20 Hz we calculated as 4 divisions into 0.1 volts, that is 0.4 volts output voltage. Now similarly you have take all output voltages mentioned frequencies 50, 70, 100 and so on up to 1 MHz. Now vary the frequency to 50 volts by rotating this knob. Yeah, now it is 50 volts. Now measure the output voltage in CRO. Just make Y position. So now it is 4.2 divisions into 0.1 volt. So note down that value here. So 4.2 into 0.1 volts, it is 0.42 volts. So now change to 70, 1 kilo, sorry 100 hertz, 200 hertz. Let me take some other values more than, let me take 100 hertz. So it is 96, yeah, approximately 100. So now measure the output voltage in CR. See, it's still oscillating. How many divisions are there? 1, 2, 3, 4, 5, 6. 6 divisions into 0.1 volts, channel 1. Okay, note down this value also. Now take all these values, 200, 500, 700 hertz. I'll show 1 kilohertz frequency now. To get 1 kilohertz frequency, I am changing the range here by pressing this button. Now it is 1K. Yeah, frequency also 1K. Now measure the output voltage in CRO. See here. So it is 1, 2, 3, 4, 5, 6, 6.1. Just move Y shift. You will get exact 6.2. 1, 2, 3, 4, 5, 6, 6.2 divisions into 0.1 voltage in channel 1. Because we connected probe to channel 1. Right? For 2 kilohertz, again you have to change the range. So here range only up to 1 kilohertz. To measure 2 kilohertz, just change the range. Now 10K. In 10K, change the range and adjust to 2 kilohertz by using this knob. Yeah, now it is 2 kilohertz. Now measure the output voltage. So by just moving some Y shift. So to measure exact value, 1, 2, 3, 4, 5, 6. It is 6.2 again. 6.2 into 1 kilohertz. Sorry, into 0.1 volts. Now I changed the range to 0.1 megahertz and I kept 50 kilohertz. For this 50 kilohertz frequency, what is my output voltage? See here how many divisions it is there. 1, 2, 3, 4, 5, 6. Exactly 6 divisions into channel 1 voltage 0.1. 6 into 0.1. Note down the value in the tabular column. So now I noted down all the values. I'll show the last value for 1 megahertz. Now I selected frequency range 1 mega and by moving this, rotating this knob, I make it to 1 mega. Okay, right? For 1 mega, what is the output voltage? To measure properly, just I am moving Y shift down. Okay, now how many divisions? 1 division, 2 division and 2.2, 2.4. 2.4 into 0.1 volts. See, now I have taken all the values for different frequencies. See here, initially the values are starting 4, 4.2, 6, 6.2 and increased. Now it is constant. See here, all values are 0.62 volts, 0.62 volts, 0.62 volts, right? From 50 kilohertz it is reducing. 6.6 volts, 0.59 volts, 0.58 volts. For 200 kilohertz it is 0.5 volts and for 1 mega it is 0.24 volts. All now the output voltage increased initially, then constant. After that it reduced. Now calculate the voltage gain. The formula is output voltage by input voltage. Now output voltage is 0.4 volts. Input voltage we have taken as 50 millivolts. Now divide 0.4 with 50 millivolts, you will get 8. Then next output voltage for 50 Hz is 0.42 volts divided by the input voltage, same input voltage 50 millivolts, and you will get 8.4 volts. So for all the values of this output voltage, you need to divide with the input voltage 50 millivolts. Then you will get the values 12, 12.4, 12.4, constant values 12.4, 12. Now it is 12, 1.18, 11.6, right? Now after this, you need to calculate gain in decibels. That is 20 log of this voltage gain. So 20 log of 8, you will get 18, and 20 log of 8.4, you will get 18.48. Similarly, you calculate voltage gain in decibels for all values of voltage gain. So now if you observe here, initially the values are less values. After that it became constant. After some frequencies at 50 Hz, 50 kilohertz, 70 kilohertz and 100 kilohertz frequencies, the value is reducing again. 2.15, sorry, 21.5, 21.44. For 1 megahertz it is 13.6 decibels. Now you need to draw the graph between frequency and voltage gain in decibels. So you should consider semi-log sheet to draw this graph. So this is the semi-log sheet. Our frequency range 20 Hz to 1 megahertz, right? So start here 10 Hz. The frequency scale should be multiples of 10. Now it is 10, 20, 30, 40, 50, 60, 70, 80, 90. Then it is 100 Hz. Then 200, 300, 400, 900, and 1K. Then 1K into 10, 10K. 10K into 10, 100K now. Now it is 1 mega. And our voltage gain range 18 maximum is 21.87 and the minimum value is 4.8. Okay, sorry, 13.6 and the maximum is 21.87. According to this, you need to take the scale on semi-log sheet. So I'll take 1 unit equal to 2 decibels on y-axis. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So here I consider 1 unit equal to 2 decibels. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Our highest is 21.8 something, right? Okay, this is enough. Now the first value is for 20 Hz, 18 decibel gain. So 20 Hz is this, 10, 20. For 20 it is 18. Just make a point here. Similarly, do for all frequencies. For 50 Hz it is 18.48, right? So indicate all points on semi-log sheet. Now indicate all points like this and join all the points. Now the graph looks like this. The maximum gain is 21.87 and now you need to indicate 3 decibel frequency, AVM by root 2, maximum gain by root 2. So for that you should take this 21.87 minus 3 decibels. So you will get 8.87. Maximum voltage gain minus 3. So you will get 18.87. Now draw a horizontal line from 18.87 now. Now the straight line will intersect your graph curve at this point. Draw a vertical line like this that represents the frequency of 50 Hz, that is lower cutoff frequency. Now this 3 decibel line will intersect at the end of the graph at this point. So note down that respective frequency, that is 280 kHz. So that is higher cutoff frequency. So to calculate bandwidth, we require these two values, higher cutoff frequency and lower cutoff frequencies. Now calculate the bandwidth, higher cutoff frequency minus lower cutoff frequency, 280 kHz minus 50 Hz. So you'll get approximately 279.95 kHz.